Yo, what's up? Sweet. Hey, what's up, y'all? Gonna connect real soon. And all of y'all, if you wanna, I guess, reorganize or pull closer to the screen if it's far, um, we're gonna plug in. And this is a special lecture, um, very special for one particular reason. Right. Zoop. Sweet. We'll be starting in a sec. I just want to verify that Calgary is on the line. Cool. Hey, if I could get like a thumbs up. Hey, what's up? All right. So let me just mute, cough. All right. Hey everyone, how's your week going? Oh man, it's week. Yeah, awesome. Nice thumbs. It's week 2, day 2. What? You're like almost done boot camp. 2? That's so close to 10. That's what I would tell myself when I. What are you talking about? It's so close. 2 out of 10. When I was in school, and you get like grades back or whatever, you're like halfway through the course and you're trying to figure out how little work can you do to still pass the class. You're like adding all this stuff up, you end up with like 38, and then you divide it by however many points or whatever you're supposed to get to pass the course, and you come out to like 12%. You're like, all right, almost there. Like I just need to do whatever I did right now, but like 4 more times to get to 48 or whatever. Like, so you're almost there. You're almost there. Particularly, I think you're getting pretty deep into the full-on web devy stuff. So this week you've been talking about HTTP. You were talking about HTTP earlier. I guess that would have been yesterday. You're gonna go notes.md. You're talking about HTTP yesterday, and today you talked about Express and web servers, and you're getting started on your first big project, your first big multi-day project being Tiny App. Our lecture today, or this breakout, don't worry, like I'm not going to throw more server stuff at you. I'm not going to throw more HTTP stuff at you. What this breakout is, it's more of like Nima's fun garden / fruit salad of cool JavaScript things. This is my new restaurant. Like, welcome. Okay, today's breakout is kind of like if you have like an Italian grandma and you get to your Italian grandma's house and your Italian grandma's like, "Oh, you look like you haven't eaten in ages." And you're like, "No, I just had breakfast." And they just shove more and more food into your face. I'm just going to be shoving more and more cool JavaScript tidbits. Like, "Oh, but have you had this yet? What about this?" And the tool that I'll be using for that, or rather the pedagogical instrument, is slides. This is one of 2 lectures that I do with slides. So lucky you. Lucky you. Again, Calgary, I don't get notifications popping up when I'm in slide mode. So if somebody from Vancouver could watch the Calgary Slack for me, that would be cool. We will not spend the entire time in slides. Like, I'm going to pop in and out. We're going to start off here. ES6 Breakout, Week 2, Day 2. Today's topics. Okay, so we're going to get through a whole bunch of stuff. We're going to talk about whatever the heck ES6 is. I'm going to start off by actually defining what ES6 is first. Talk about ecosystem. Ignore the word strict. I'm skipping that today. And then we're going to look at some cool ES6 features. And then if there's time, we'll talk about some other stuff. I want you, again, just to think about the stuff that I'm talking about at a high level. Think about concepts. I'm going to be giving you a bunch of little snippets of code. We're going to play with some stuff. But I want you to play around with it after Breakout, right? And just kind of get used to some of the JavaScript things. You can pick and choose. You can pick and choose from the things I give you. Some things are going to be cool, and you're like, oh, I want that in my project. Other things you can be like, I'm never going to do that ever. That's fine. There's going to be 2 things in this breakout that I will ask you to have in your Tiny App project. Only 2, and I will tell you what they are when we get to them. All right, ES6. It's in the game. No FIFA players here. So ES6, also known as ES 2015, because why not? 6, 2015, same number, pretty much. So ES6 is the 6th version of a particular thing, ES. And it was released in 2015. So you'll see it referred to in the same kind of way, 2015 or 6. ES stands for ECMA. ECMAScript, which is somehow related to JavaScript. Now, ECMA stands for the European Computer Manufacturers Association. You're like, cool, that was on the slides, Nima. What does that mean? So ECMA is basically this. I don't know if any of y'all have played like Skyrim and seen the Greybeards. ECMA is basically like a bunch of people who meet somewhere in Europe, just a bunch of nerds. They get together and they disagree and they argue and they come up with a specification of what ECMAScript should be. Right? ECMAScript being this imaginary language, right? This imaginary language that should exist. They say, what if there were for loops? And somebody says, I hate for loops. And then they argue for 3 weeks. And eventually, after a couple years, so namely 2015, they put out a document and they say, hey, you know what? We've agreed. This is what our version of this beautiful programming language should be like. They don't actually make the language. Like they make what the language should be. So they'll say things like, there should be a for loop. Right? Like this language should have fors. This language should have functions. But they don't actually put in the work to make it. It's up to people afterwards to take that specification, and implement it. So the specification is ECMAScript, and the implementation of that becomes JavaScript, being an actual language that exists, does stuff. And we're going to look at that a little bit more in depth on the next couple slides. Now, yes. I remember there being like, so if we look up ECMAScript, I'm pretty sure ActionScript is, yeah. So other implementations, so JavaScript is the main one, but then there's also a language called JScript, different than JavaScript. ActionScript. So JScript I think was Microsoft's. No, Ole. Yeah. But yeah, ActionScript, another language, and they're like similar. They're all very similar. They're all essentially related to JavaScript. Right? So JavaScript comes out of the ECMAScript specification. Now, you don't need to know this. This is just cool history. This is like, did you know ECMAScript is a thing? Now, ES5, so the 5th edition of the ECMAScript standard, was in 2009. What? 2009 to 2015 for a new version? What is this? Like a new Game of Thrones season? Like, it took so long for a new thing to come out, right? And things had changed. Between 2009 and 2015, stuff had changed. Now, one of the questions that people kind of think about when you see that a new version of a language is out is, why do we need new standards, or why do we need new versions of a particular language? I've broken it down to 2 main points. First, we find better ways of expressing ourselves. Right? We find better ways of expressing ourselves, and our language should adapt to that. So, I used to maybe say word to mother, and now that's like not as cool. We found better ways of expressing that same feeling, right? I'm still, like, Archie, can you once and for all explain what yeet means? Yeet. See, there we go. So apparently there's this word yeet. I still don't understand it. It's used on our social media sometimes. Is that what it is? Yeah. So languages just change. They just change over time because we find different things that we want to say. There's also the fact that the problems that we're facing change over time. There didn't really need to be a word for debugging before programming became a thing, right? Troubleshooting, right? Those are all words that arise out of new problems that appear over time. Now, speaking of things happening over time, we need to jump way back into JavaScript history and just very loosely understand the origins. JavaScript is not a language that just popped out of the sky, right? JavaScript is a language that came out of the need for a programming language to exist in a browser. So JavaScript exists originally for one reason. There was a browser called Netscape Navigator. At the time, browsers were just used to look at HTML and CSS. And the people making the browsers said, hey, it would be cool if we could embed little programs into our websites. So this person who worked at Netscape, which I guess, Brendan Ike, I wrote Brandon by mistake, but Brendan Ike said, hey, you know what, I'll make a language that we can embed into our browser. And it took him 10 days, just hacked together bits and pieces of a language being inspired by other languages that already existed. Right? Took a look at Scheme, Python, Perl, just other languages, and hacked together something that worked. Now, there are parts of JavaScript that you may like and parts that you might not. After boot camp, right, or even during boot camp if you find the time, you might find it interesting to explore parts of JavaScript. Be like, wait, where do callbacks come from? Right? Maybe callbacks come from Scheme. Maybe callbacks come from Python or something else. Now, JavaScript is not the same as Java. They're actually not even really related as languages. JavaScript is to Java, is hamster is to ham, right? I'll rephrase it. Java is to JavaScript as ham is to hamster. Not the same thing at all. Not even closely related. The only way they're kind of related is when JavaScript was made and named, Java, another programming language, happened to be popular at the same time. So the people who made the language were like, it would get us some good views. It would really hook people in. As if we called our language JavaScript. Yeah. It's your typical kind of phishing scam or whatever, where you like hook people in by accident. It's your clickbait. It's your clickbait of 1995. Okay, so that being said, JavaScript is a language. A programming language is just this really general tool that's used to do things, to communicate with someone, right? Generally to communicate with someone in terms of loops, if statements, variables, functions. But other than that, it's really up to you what you decide to do with the language. Now, I use English to communicate with people, to ask them to do stuff. Right now, I'm using English to communicate with y'all, to get you to learn things. But I might use English to like ask somebody to do something for me, right? Or I might use English to like order food over the phone, right? It's a very general language. JavaScript is the same kind of deal. We need somebody on the other end of our communication to listen and understand and then act on the instructions that we're giving them. We're going to deal with JavaScript over the course of this bootcamp in 2 different places, right? One of the places is our browser. So in your browser, that's the original place where JavaScript is used, right? We can write JavaScript code, and your browser actually has a program inside of it called either V8 or SpiderMonkey if you're on Chrome or Firefox. Those programs like V8 and SpiderMonkey are called engines, right? They're a program that listens for some JavaScript code and then runs it and does something with it. So Chrome and Firefox each have V8 and SpiderMonkey, respectively. So a browser can look at HTML, it can render like CSS styling, and it can also run JavaScript code. We'll also be using, and we've already started using, JavaScript on our computers in terms of Node.js. So we'll be building servers over the course of the bootcamp. Many of our servers will be built with JavaScript on the same engine that Chrome runs, the V8 engine, but it's going to be used in a different program. Instead of being run in a browser, it's going to be running on Node.js, right? Just another program that listens for JavaScript and runs it. Notice that these are all different programs. V8, SpiderMonkey, Safari has one, and I can't remember what it's called, like the Safari JavaScript engine. It was called JavaScript Core. No, WebKit, used in WebKit project. Look, Nitro, Squirrelfish Extreme, right? All these different engines that are really just programs that listen for text. They listen for the text that you're writing with your keyboards, and they'll interpret it. Now, they should, as they listen to the text, end up running it in the same way. But they're built by different people. So the people at Google who built V8, or the people at Mozilla who work on SpiderMonkey, they need to look at the specification, the ES6 specification, right, and build their program so that their program behaves the way that you expect it to. This kind of explains why you might have heard some developers complain about how making things work on Internet Explorer is difficult, right? Because the people who made Internet Explorer didn't keep up with the specifications, right? Because these are things being built by many different people. Now, as we talk about these specifications, every time a new specification comes out, usually it's a bunch of additions to the language that make it either more intuitive or faster or easier to use. They're generally new features that you can choose to partake in, right? The way that these specifications roll forward is generally speaking, so that old code still works properly, right? But we'll be writing code that uses those new features that might not work on old engines, right? Now, ES6 has been around for quite a while now, since 2015, so the people who make the big projects like Chrome and Safari and Firefox, Node, they've all had time to catch up and make sure that all the things we're going to look at actually exist in their things. But it's something that I want you to think about. As new features come out for something, right, it might make the new thing incompatible with the old thing. So we're going to make our way through like a list of the new features in JavaScript. Some of these you've already seen, so this is just going to be a bit of a review, right? The first one is ES6 gives us nicer loops, just more options for loops than we did before. So if I was to, I'm going to hop into the console on the browser, and I'm going to do all my work in here. Right? I'm going to write all the code that I'm going to be playing around with in the browser, and then I'll send you like a long script with every example that I'm doing. So traditionally, with JavaScript, what we have access to is the, we're going to pop this out. Pop, and pop, okay. Traditionally, what we have access to in JavaScript is if I have an array, like var array equals 1, 2, 3, 4. Actually, we're going to do something else. We're going to do A, B, C, and D. I have some options for how I'm going to loop over this. For var I equals 0, while I is less than array.length, I++. And then what do I have to do in here to console log an element of the array? Well, I have to go console.log array square bracket I square bracket, and then. This is a lot of work to go through. There's a lot of places where I might make mistakes. I might accidentally go .i, right? If I go .i, then this thing doesn't work. I might accidentally go from var I equals 1, and now I've missed the very first letter. Just trying to show that there's plenty of places where I might make a mistake. So in earlier JavaScript, what we had in addition to this was a thing called for each. You can make a for each function, or you can use the for each function to which you give a callback. You say for every, for every element, console.log element. And this ends up working, right? It's a thing that's built into JavaScript. But I think this adds a little bit of confusion, because now we have to talk about callbacks, right? And maybe you're not comfortable with callbacks. Now we have to talk about the fact that this for each is not written in the style of a for loop. Blech. There's also some other things about this that I'm not going to go into right now. But what ES6 gives us is for var I of something. So if I rewrite my loop like this, I can go console.log I. And now I've written a for loop that loops over absolutely everything in the array. I didn't even have to worry about indexing stuff. So in fact, I might even rename my variable I to element. Oops, not like that. I might even rename my variable to element. And this is just so much more legible than what I had before, right? I don't need to worry about stopping conditions and incrementing and yada, yada, yada. Because most of the time when I'm looping, the fact is I need to loop over everything. If I needed to do some limited looping, maybe I'd use a traditional for loop, but now I can use this. I have for var element of, and I also have element in. When I use in, what do I end up getting back? The index of the particular elements that I'm at, right? So I can use of to go over every element, or I can use in to go over every index, right? Easy way to remember that is in, short for index. That's the way I try to remember it. Interestingly, I can use this of over objects as well. So say I have an object. Var obj equals this object that goes A1, B2, C3. I can go for var thing in object, and this handles that thing. If I go for var thing in object and I run this, what do I get back? If that was my original object here, what are the A, B's, and C's? The keys, right? Remember that. In is going to go over the keys of the object. And if I try to do of, it does not work, right? The people who made JavaScript just decided, nope, we're not going to make for of do anything for objects. We can only do for in. Right? This is just a cool addition. Good quality of life for you as a developer, when I need to loop over an object, I can do this. Maybe if I want to grab every item, I would do in, and I would do key, and I would go obj square bracket key. And that gets me every single one of the elements. Neat. Any questions about this? I hope to see you use for of regularly. For of and for in. I want you to see you use those like straight up everywhere. Now, the next thing that we're going to talk about is let and const and var. I know you've already done a little bit of reading on this, but I want to clear up any misunderstandings. The problem with var is that var does a thing called hoisting. var hoists declarations. The way I'm going to show that is I'm going to do this. I'm going to make curly braces. And the reason I'm doing curly braces here is just to declare some scope. I'm not making curly braces for an object. I'm making this just so that I can write a couple lines of code together and run them at the same time. What do you think happens if I go console log food? If I was to run this right now. I get an error, right? Food is not defined. That's a good error to have because I don't have food. Right? Food is not defined. If I go var food equals potato and I run this, then I get potato. Excellent, fine. var food equals potato. I try to console log it. It exists. What happens if I take this and I move this to be under? So this is weird because I'm trying to console log food, but food is not defined. I haven't said what food is. So it turns out that what JavaScript does with var is it'll take that code, it'll take that declaration, and it'll actually split it into two lines without asking you. This is what it does automatically. So me writing this ends up turning into almost this. What it does afterwards is it takes the declaration and it moves it to the top of the scope. Moves it to the top. So I wrote this code, but I actually generated this code. There's nothing necessarily wrong with that. It's just unexpected. It's not the way that you as a new developer would expect JavaScript to work. So it can cause a lot of weird bugs. It can cause a lot of weird bugs when var doesn't act the way you expect it to. Another thing that's weird about it is when I run this thing here and then I go food has technically like escaped the scope that I set for it. Right? I said it should only live within these curly braces, but I'm actually able to access it outside now, which is weird. You can also see this in a for loop. If I wrote a for var I equals 0 while I is less than 10, I plus plus, and I just run this loop, I actually have I be 10 now because it escaped from the for loop, right? It was like nobody's watching and it just kind of jumps out. So instead what we're going to be using, and what I urge you to use, is let. If I redid this here with let food equal potato, I actually get an error. It says, hey, you can't access food before you initialize it. Right? That's a good error for me to have. If I use let in my for loop, and then I try to go I, notice that I is undefined, because it didn't escape from that scope. Right? These are good things, and it behaves more intuitively. Again, it's not that var is wrong, but var is so confusing that it alienates a lot of people. So ES6 gives us let, which kind of behaves the way you thought var behaved, and it also gives us const. And const is going to be interesting Because what a lot of people think const does is it gives you a value, name, we'll do, yeah, name Bruce Wayne. A lot of people think it gives you a value that you can't change. Because I can't go name equals Clark Kent. Once you've made a const variable, you cannot reassign it. You can't reassign a constant variable. You can only declare and assign it once. But what's interesting about const is that you can modify the value. If I had const pizzas, I can't go pizzas equals cheese and margarita. I can't do that. But I can change pizzas to remove an element. Right? Pizzas is an array, and arrays have a pop method. So when I go pop and then I check pizzas, I'll notice that pizzas has been modified. If I go pizzas and I go push, I can go pineapple. Is that how you spell pineapple? Yeah? It's a weird word. And I look at pizzas now, I'll again see that pizzas has been modified, but I had to be very deliberate about the way that I was modifying this. I can't reassign it. This is just a nice extra tool to stop you from accidentally reassigning a variable. Because that's a place where a lot of people introduce bugs. So ES6 tells us, hey, const is like an extra safe variable. I can also take pizzas and change the second one to anchovies. So see that I can change the things inside of pizzas. And I can add one. Pizzas 3 equals potato. But I can't reassign. The same thing's going to go for objects. If I had const obj equals E, C, Y, and A, I can go obj2 dot E equals something else and change it. I just can't reassign obj2. So my recommendation for you, or rather my decree for you, is going to be, from now on, when you're working in JavaScript, use const. When you can't use const, use let. Right? So you use const, and if you can't, then you use let. And this is going to be in your Tiny App. I want you in your Tiny App project to use const and let. Are there any questions about this? var is still part of the language. We just won't use it. You might find that when you look at old code or documentation, people might still use var. I want you to ignore that and just kind of go, pfft, that's old news. Sweet. So really, like that right there, the const and let, that's the first thing that I really want you to do. Right? That's the first thing that I really want you to do. The fancy for loops, like, they might be useful for you, but const and let, that's like Nima's stamp of approval or demand. Okay, here's after that big meal, here's a fun little treat. Fancy string interpolation. So ES6 just gives us a nice way to put values into strings nicely. I used to maybe make, if I had var name equals Bruce Wayne, and I wanted to say something like, Batman is actually name. What? Shocking. But I had to like use pluses and stuff. And if I needed to do like a bunch of this, like put a lot of values in here, this would just turn into like a mess of plus quote whatever, plus value, plus quote whatever. You've already probably found yourself doing this, and it's a pain. It's just annoying. We get nice little backticks. I call the backticks either fancy strings or like the kawaii, like cute strings, because when I do these, it reminds me of these faces. Like, they're just so cute, right? Like, they're just cute little strings. You know, they're cute. But what I can do with them inside of here is I can say Batman is actually name. All right. Wham. This is just more legible. The other nice thing about this, the backticks, is that I can have, like, if I wanted a string that spanned multiple lines, as a regular string, I'd have to go \n, \n, and this prints it on multiple lines. If I wanted to like actually have spaces like this, oh whoops, no, let me, like I can't do this with regular strings, it'll break. But with backticks you can. Hey, what up? Haha, and then end it. They're all on different lines, which is cool. By the way, if you're ever looking for these little faces, they're called cowmojis. Cowmoji. So there's like a website that I'll put into your Slack. Like I don't like watch anime. I just think these faces are hilarious, and I want them to be in more of your console logs. Just, you know, if you're ever feeling angry, you can put one of these faces in, or this little dude. There's one for throwing a table, but I can't find it. Oh, there we go. Throwing table in anger. That's putting the table back. So just, you know, cool. It's not necessary. Like, you don't need these fancy strings, but why not use them? Okay. Have that nice little treat. I'm going to throw another kind of important thing at you. This is another thing that I'm going to require you to play around with a little bit. Right? I'm going to need you to play around with this. So, arrow functions are a new way to make functions in JavaScript. Let me check. There's no questions from Calgary? No. Arrow functions are a new way to make functions in JavaScript. Basically, we'll have this. Let me go blank. I just need a blank page to have the console open. There we go. So, I could go say hello, be a function that console.log hello, and then I can call this as say hello. Like, that's just my typical function. You've been dealing with this since the prep course. But now, I might go const say hello equals console.log hello. And this is going to be useful for us for a couple particular reasons. Let me run this. I now have a constant variable, say hello, which is a function. And this is new syntax that's going to make some things a little bit simpler. If I need a function that returns the number 4, I might make this function const make 4. And that's all that I need to do now. I've made a function that returns the number 4. I can call make 4, and that'll get me the number 4. Notice that I didn't even need to use the word return. If my function is really just one return statement, if it's just one return statement, I don't even need curly braces. I can write it as, this is what the function takes, and this is what the function returns. Notice right now, my function's not taking anything. Let me make another one here. Const make greeting. This one's going to take a name, and it's going to return a string. I'm going to do my fancy strings that says hello name. Again, this is a function that takes in a name, and it returns hello, comma, name. And if I go make greeting Belinda, Hello, Belinda. Bradistopher. Right? And it's nice because I was able to just write a single line that does this. You know what's really cool is if I need a function that only takes in one input, I don't even need these parentheses. Now this syntax can be freaky to you the first time you see it. I just want you to get comfortable with it over time. Any one of your functions so far can be rewritten as arrow functions. So the rule for that is going to be your parameters are going to be, if you have multiple of them in brackets, if you only have one, you can go name. If you don't have any, you just have empty brackets. Then you have this thing, an equal sign and an angle bracket, which we call the fat arrow. Fat arrow, and then after that, what you can do is you can either have curly braces and do a bunch of stuff and then eventually go return, whatever. Or if you only have a return statement and no other body in your function, you can just straight up go fat arrow points to the return value. Couple things to note. Arrow functions, you can't just declare them like this, because they are by necessity anonymous functions. They don't have a name. So if I make this function like this, I don't know how to call it anymore. Right? I just don't know. So what we're going to need to do is, if we want to keep them, we have to put them in variables. So that's one thing to note. Arrow functions are often used as callbacks. So if you were doing like your was it get HTML, I guess you were working on yesterday, that then took like something. Does this look kind of familiar? Right? Developers just get angry about the word function. So you can now rewrite that as that. Technically nothing else changes. Right? It looks a little bit shorter. If your thing only has a return statement, again, you can do this, and that's a bit nicer. The reason I say that I want you to play around with this stuff over the course of your Tiny app is I want you to see if you can take your, you were looking at app.get this morning, for example, right? Am I correct? I want you to see if you can do things like that. App.get, and then write your callback here as an arrow function instead of writing it as this. You're going to see the benefits to this over time. This isn't going to be beneficial immediately, but I want you to get into the practice of it. Right? Now, there is one thing that I do want to mention in a second, but does anybody have questions about arrow functions right now? Yes? So the question here was, when do I want you to use arrow functions? Should you use arrow functions in global scope? I'm going to say, try to use arrow functions absolutely everywhere. Right? Anywhere you're making a function, try to see if you can change it to be an arrow function. Right? One thing that you're going to discover about arrow functions is that arrow functions are not affected by hoisting. Right? So you might have noticed as you were working on your project that let me go. You might have noticed as you were working on your project, so you were able to do things like this. Like I can put function say hello down here. And up here I'm able to go say hello even before I ever declare the function. So functions in JavaScript, they get automatically moved up to the top when the code runs. With an arrow function, I need to I need to have the declaration happen before the invocation. Right? Arrow functions are going to force you to write code like this, which is nicer. You want to declare your function before you use it. With an arrow function, your JavaScript code just won't run if you don't write it right. Right? So that's one of the reasons. Right? Does that kind of answer that? Like, I want you to use them everywhere, especially when you're doing callbacks. The one kind of thing that you're going to find with arrow functions is that arrow functions do not have, and I'm going to really briefly skim through this, arrow functions do not have their own this. So I don't think you spent a lot of time with this just yet. If you feel kind of like you know, confusing yourself just for fun once in a while, console log the word this and see what it is. Right? You're going to be talking about this later on in boot camp, like in week 6. You're going to be talking about it a little bit next week. But I just want you to make a note right now. If your function works as an arrow function and doesn't work as a traditional function, or the opposite, and you have the word this in there, right? Then you're running into an issue with this binding. That's all I need you to know. Is if you run into some issues and the word this is in there, message me. Or tell a mentor, hey, does this have anything to do with this binding? Right? And that's all you'll need to kind of say to then learn the next little bit. Right? I just don't want to throw more onto your plate than you need right now. That sound good? If this is interesting to you, I have put in the notes that you get an example. There you go. Bind. There you go. I have put in the notes an example where the same code prints out something different when it's written as an arrow function versus when it's written as a function. Okay, so you can play around with this if you want to see what happens. But one of them is going to print out rainy, and the other one's going to print out sunny. Right? Again, I want to stress, this is not important right now. But I'm just doing my due diligence by letting you know that this is a thing. Is that okay? Are we okay with moving on from that? Cool. Any questions from Calgary? Can I get a no? Can I just get a no? No questions? Unless you're thinking really hard. Oh, Peter. Peter. No. What did you see, Peter? Oh, okay, just no. Right. So, moving on. The last couple of things I'm going to show you are really just more fun stuff. Here's one. Destructuring objects. Just another thing that ES6 introduces. I don't know if you've ever tried to get a bunch of values out of arrays or out of objects. It is lame. It's boring. It takes a lot of code. Example here. If I have var pizzas, not var pizzas, we're going to do const pizzas. Here's pizzas, and maybe I wanted to go const pizza 1. Or, we'll do like Nima's pizza. Be pizzas 0. Right? And anybody else want pizza? I'm ordering. Yeah? Turner. Const Turner's pizza. Right? You're going to get the margarita. Beautiful. Anybody else want a pizza? No? Yeah, sweet. So const, well, pepperoni is, well, I'm just going to say that it's gluten-free. Devin's pizza is pizzas 2. Look at how much work it took me to do that. Oh, man, right? If only there was an easier way, and there is. Here is pizzas, and if I wanted to say const Nima's pizza, Turner's pizza, and Devin's pizza is pizzas? What? That's legal code? How's that even legal? What? Every time I do this, I get nervous that somebody's gonna like just kick through the window. Get down! You're not supposed to know about that. What? Nima's pizza is cheese? What? This is called destructuring. Destructuring of arrays. And what it's going to do is it's going to go in order. So say I had a bunch of pizzas. So pepperoni, anchovies, pineapple. Right? If I ran this, it grabs the first three. Right? So Nima's pizza is cheese. That's useful for when you want to grab the first, second, third parts of a thing. Often you'll see people write it out as first, second, to make variables that are called first and second. You can do this with const. You can also do this with let. Can you do it with var? Absolutely. Should you use var? Never again, right? Like, just do const and let. Identifier first has already been declared. Is this cool? It's neat. Do you need to do it? Absolutely not, but it's fun. This also works with objects. So if I have const, do I have phones? Friends. We'll do friends. I'm going to toss some of my friends in here. We're going to do Hussein. Hussein, phone number. No, we'll do how much I like them. I like Hussein 3. I like, we're going to do Jason. I'm going to give Jason an A+. Going to give Andrew. Andrew's going to get Wu-Tang Forever. I have a particular rating system. Notice that I don't have a variable called Hussein. Yet. I also don't have a variable called Andrew, for example. But what I can do is use very similar syntax to before and go Hussein, Andrew. What? This shouldn't be possible. No one should have all this power, right? What? And I've pulled out Hussein and I've pulled out Andrew, right? Easy. One line. Go grab the things you need from the objects, put them in a variable. We're ready to move on. Right? Again, it's not a thing you need to do. I could go const Hussein equals friends.Hussein. Right? And then same with Andrew and everybody else. But really, it's like, let's just cut that out. We'll do it in one line. Right? Is this cool? It's pretty neat. I want you to play with it. I'm not going to force you to use it, but it's pretty neat. And that's going to be, like, honestly, my theme for this stuff, right? If you look back, it's like, most of it's just kind of neat. You don't need to get overwhelmed by all of it and be like, oh man, now I need to know about object destructuring. What? But it might help if you make it sort of part of your workflow over time. Okay, destructuring objects. And I think what we're going to do is we have time for one more fun little tidbit. It's the last little, it's like you're going away, you're leaving Nona's house, have one last cannoli before you go, right? And this is spread syntax. Spread syntax starts off sounding kind of complicated. Allows an iterable or object to spread where necessary. And you're like, what's an iterable? Oh, any object that can be iterated over. What's iteration? Taking each item of something one after another. Like, Nima, this is a lot of stuff. But where this is going to be useful is when you're dealing with arrays, objects, and possibly strings as well, where there's a sequence of stuff. So here's what I'm going to do. I'm going to make an array of TV shows. So Game of Thrones. We're going to go Star Trek. We can go Zoe 101 A, and we're gonna throw in New Girl. All my favorite shows. Is it Zoe with 2 O's? Who knows? And now what I want to... Oh, I didn't actually save this in a thing. Const TV shows equals that. Now I might want to make a new TV shows that has everything that TV shows had, plus some other stuff. And one of the things that I can do with spread syntax is I can take TV shows and go ... What ... means is take the TV shows and spread them. Kind of like when you're spreading butter over bread. Just that's why it leaves the little ... trail. Spread. Right? I think it makes sense, right? Just whoosh. I go TV shows and maybe I throw in another TV show. I'm watching Brooklyn 9. I can't spell. Is it 2 N's? Who knows? Huh? I got it right? I should stop double guessing myself. And look at that. I got all of the TV shows plus Brooklyn 99. A little bit of spread. And it's just nice because when you look at this enough, you're like, oh yeah, like I get it. All of the TV shows and then Brooklyn 99. And you know what's awesome about this is like I don't even need to do things in a particular order. I'm just gonna go const nums equals 1, 2, 3, 4, 5, and I'm gonna go nums, and then haha, and then ... nums again. Let me toss in another one, nums again. Whoops. Right? I'm just spreading. This stuff's free. It's free. Just keep doing it. Does this syntax seem kind of cool to you? Right? And they've tried to pick some syntax that's kind of like intuitive. We're gonna go like 2 minutes over. You can do this with objects as well. If I have const obj equals 1, 2, 3 on the ABCs, and then I have const obj2 happening to be E, C, Y, A. Let me change this a little bit. A, B, C, D being 4, and then E being 5. So I have 2 different objects. I can go ... obj1 and add other things in here, like hello world. Sorry, it wasn't obj1, it was just obj. Hello world. To make a new object that has 1, 2, 3 and world. And what I can also do is I can merge 2 objects together. What? Have you ever thought about how you might merge 2 objects? You'd have to write like for loops and stuff. No more for loops needed. You just go and spread it. What's interesting is if I have 2 objects, like I said, const obj and obj2, and notice that my obj2 has some keys like C and A that actually overwrite this one. When I spread them together, it'll nicely overwrite. That could be useful to you. Kind of cool. Kind of cool. Any questions? Yeah. That's a good question. So from Calgary it was, what if we reversed obj and obj2 in the spreading? Would the overwriting be different? Yes. Yes. And that's a great question, and that's the kind of stuff that I want you now to take these new tools and just budget some time to play around with it. Right? Just tinker. Tinker. That's how you get like a full kind of multi-dimensional understanding of the tools that you're working with. Right? Look at that. It's free. I could just keep running it. Right. Sweet. Questions from Calgary? I'm gonna zoom in on Peter until Peter says no again. Are there any questions from Calgary? Oh, Peter, please, Yes, okay, there we go. No. I have now selected Peter as our, I don't know, I'm going to pick a nice emoji. Just a nice, Peter is our no star. So just tell me no whenever, and we'll move on. In that case, that really brings us to the end of what I want you to see today. There's some other stuff that I haven't talked about in the little code notes that I'll send you. Run them, kind of see what happens. When you look at the code notes, I have split everything that I've talked to into little bits with some commentary, right? And you can copy and paste each one of these things into a file or into your console to run them independently, right? Because I think towards the end of it, I put in some code that's supposed to break it. So if you run all of it all at once, it might just break. Then I have some other links. Something that you might want to check out is a website called ES6features.com or org. This just has a nice list of all of the new features from ES6, but it's much drier than, listening to me talk about it. So it's like, oh, here, this is what we would have done before in ES5, and this is what I do now with ES6, with arrow functions. Or same with template literals for string interpolation. They're like, this is what you used to do, and this is what you do now. Cool stuff. I'm going to use a word before I let you go. Syntactic sugar. Right? Syntactic sugar means making some stuff that makes your code a little bit sweeter. It's just a little bit more palatable. It's just nicer. So things like that string interpolation, we'll call that syntactic sugar, because your code ends up going like, this is good code, right? I could eat some more of this. So I'm going to leave it at that. Thank you, Calgary, for tuning in. Peter gave me another no. Thank you for tuning in. Have a great rest of the day, and I will see you next time. If you have any questions, just message me. Great. Thanks, everyone.